welcome back to the maths class once again. In today's session, I'm going to discuss with you exercise 10.4 of class 9th of the chapter surface areas and volumes. Now we were dealing with these chapters in so many video lessons. Those are all in the playlist of the channel. Okay, you can observe them just clicking on the playlist. Okay, wherein you will find all the video lessons of this chapter. Now in the continuation part of 10.4, we have done in the previous video session, the 10.4, the problems up to, I think, up to 8 problems. Okay, those who want to watch the before problems, just click on the iCard, you will be notified. Then let us continue. Let me continue from the 9th problem. I'll read out for you. Diameter of a lead ball is 2.1 centimeters. The density of the lead used is 11.34 grams per centimeter cube. What is the weight of the ball? Here in this question asked the weight of the ball, that is a mass of the ball. This lead ball, it is spherical. We know the lead balls, isn't it? Yes. The density is given. Here we know that the density, what is the formula for the density? The density is nothing but the mass by volume or weight by volume, right? Weight by volume, mass by volume or weight by volume. Here given a lead ball. So the lead ball is spherical in shape. And what more information is given? Here the diameter of the lead ball. This is the lead ball. The diameter is given. D is given as 2.1 centimeters. And the density here, the density of the lead ball given as is equal to 11.34 grams per centimeter cube. So this is the density. So the units are weight by volume, isn't it? Grams per centimeter cube. Given that the diameter, so the diameter is given, so the radius is equal to 2.1 by 2 centimeters. Right. Now here we will find the volume. And if you cross multiply the volume with density, we will get the weight. We are asked the weight of that lead ball. So let us find the volume of spherical sphere, isn't it? The lead ball, spherical lead ball is equal to the volume of the sphere is 4/3 pi r cube. So that we will substitute 4 by 3 into 22 by 7 into the r value is 2.1 by 2. So 2.1 upon 2, 2.1 upon 2 thrice cube, isn't it? So r cube. We will cancel off 2 and 2 goes with 4. So 3 ones 3. 0.7 7 3 is 21, isn't it? So here again 7 1 7 7 0.1s, right? And what else left over? 2 again, 2 ones 2 11s. So the what are left over? So 11 into 0.1 into 2.1 into 2.1 here. See 21. So remove the decimal points, first multiply 21 into 21, we get it as 441, 21 square. Right, into 0.1 into 11 here. So 11 ones are 11, but point is there 1.1 can write, and 4. Okay, after 2 digits, so this 4.41. So let's multiply 441 multiplied by 11 here. So that comes to 441. 441, 158 and 4. Right. So 4851 after 3 digits point from the bank. So 4.851. This is the volume of one lead ball, spherical lead ball. So it is centimeter cube. This is the volume. Now we are asked the weight here. The density is weight by volume. We know that. Okay. Here asked weight of the lead ball. So if you cross multiply these two, volume into density, we get the weight. Okay. So weight we will find out, volume is 4.851 and the density given as 11.34. So let us multiply that. 4851 here, 4851, 1134. So do this multiplication part. Removing the decimal point, do the multiplication part, you will be getting around 55 point somewhere. So 55.01, so grams. Okay. So we can take it approximately. So 0.1 is a minute one. So we can take just 55 grams is the weight of the lead ball. Weight of lead ball. So what we have done? We have calculated the volume of the sphere multiplied by the density which is given in the problem. We found out the weight of the lead ball. Please pause it and note it down. Let's see the next one. The 10th problem, I'll read out for you. A metallic cylinder of diameter 5 centimeters and a height of 1/3 centimeters is melted and cast into a sphere. What is its diameter? Now, there is a cylindrical metallic one piece, okay, that is melted and cast into a sphere. Now we have to find the diameter of the sphere. So when you are changing, when you are melting and casting into another 3D figure, there won't be any change in the volume. That is the concept. Okay, so one metallic cylindrical shape metal is there in the form of a cylinder. This is being melted and cast into another 3D shape. The other 3D shape is the sphere. Okay, so this is the sphere. So there won't be any change in the volume. So we can equate the volumes here, right? And we are asked here to find the diameter of this sphere. Okay, what is given here? We will find out first. So the H value, the height of the metallic cylinder given as 1/3 centimeters, that is nothing but 10/3, changing into the improper fraction. Okay, 10/3 centimeters, and the radius of the metallic sphere, diameter is given as 5 centimeters. So the radius is 5/2 centimeters. We have to find the same metallic cylinder is being melted and cast into a sphere. So there won't be any change in the volumes. We can equate the volumes of both the solid objects, right? Let us find here volume of the metallic cylinder. Okay, here just the volume is pi r square h is the volume of a cylinder. So this is the metallic cylinder. We will substitute. Okay, 22/7 into r value is 5/2 into h value is 10/3, right? This volume is melted and cast into this form. So we will equate it to the volume of the sphere, volume of metallic sphere is equal to 4/3 pi r cube. This is the volume of sphere. So that means 4/3 into 22/7 into, we don't know the r value, r cube. So we will equate them. So 22/7 into 5/2 into 5/2 into 10/3 equals to 4/3 into 22/7 into r cube. So the pi value we can take it off. Here shift this to the other side. So that becomes 5/2 into 3/4, the reciprocal. Here that comes to r cube. Now we will cancel off here 3 and 3 goes off here. Yes, 2 2s, 2 5s. So we have 5 5 5 and below we have 2 2 2. So this is r cube. Clearly r value is 5 upon 2. This is the radii. But here ask the diameter of the sphere. Okay. So diameter is twice the radius. Diameter of metallic sphere equals to 2r, that is 2 by 5 by 2. So it comes to 5 centimeters is the diameter of the sphere. Pause it and note it down. How many liters of milk can a hemispherical bowl of diameter 10.5 centimeters hold? Here given the hemispherical bowl, okay. So how many liters of milk it will hold? Hemispherical bowl here. How many meters of milk it holds means the volume of the hemisphere we have to find. Given for us the diameter. Diameter is given as 10.5 centimeters, I think. Yes. Yes, 10.5 centimeters. Yes. We will find the volume. Now which sum is this? This is the 11th problem. So volume of hemispherical bowl. Okay, the volume of hemisphere is 2/3 pi r cube, right? So here, from here we can write that radii is 10.5 upon 2, half the diameter. So 2 by 3 into 22 by 7 into 10.5 by 2, 3 times r cube, isn't it? Now we will cancel it off here. 3 ones, 3 thrice and 3 fives. Okay, 7 ones, 7 0.5s. 7 fives, 35. Here 2 goes off here. 2 ones, 2 11s. Still what are there here? That's it. So 11 into 0.5 into 10.5 into 10.5. Here 11 into 0.5. So half of the 11 is nothing but 5.5, isn't it? So 11 into 0.5. That means half of 11. Half of 11 is 5.5 into 10.5 into 10.5. Still there is 2 here upon 2. So I have forgotten 2. So upon 2 is also there. Right. Here let's just directly multiply in the rough part. 105, 105. Okay. 5 5s. Here, okay. 2 5 ones are 5. So 0. So that comes to 5 0 1. So 5 2 1 1. So 5.5 into 2 5 after 2 digits. So this comes here. So again multiplying it with 55. So 5 5s 25, 2 5 2s 10 11 12, 1 5 1s 5, 5 1s 5. The same thing, 5 2 1 5 and 5. So 5 7 3 6 10 6. So this comes to 606.375 because 3 digits, okay, divided by 2. So clearly we can write it as 303. Okay, 2 ones 2. This fraction part we can eliminate here. So this is a round figure. We can also take it as 606 upon 2. Okay, approximately, right? So that comes to 303. 303. What is it? This is the centimeter cube. Yes. Now here asked milk, isn't it? So how many liters of milk? So let us change into liters. So 1 liter is, if you are changing into liter, you can write it as divided with 1000. Okay. If you divide it with 1000, you get this many liters. Yes, that is 0.303 liters of milk it holds. Right. So pause it and note it down. Let's see the last problem. Now the last problem of this exercise, 12th one, a hemispherical bowl has diameter 9 centimeters. The liquid is poured into the cylindrical bottles of diameter 3 centimeters and height 3 centimeters. If a full bowl of liquid is filled in the bottles, find how many bottles are required. Here a hemispherical bowl has diameter this much. So let us draw that hemispherical bowl. Okay. And there are cylindrical bottles. Likewise, how many bottles we have, we don't know. Let us suppose it as n bottles. N bottles, cylindrical bottles. So a liquid is poured into these bottles full, and these bottles are being filled, that liquid is being poured into the hemispherical bowl. Okay. Now how many bottles will fill this hemispherical bowl is asked. Okay. So if we find the volume of these cylindrical bottles into n, we don't know how many bottles into n, that if we equate it to the volume of the hemispherical bowl, we will get the n number. How many bottles it will require to fill this hemispherical bowl, we will find out. Okay. Now the given information we will write hemispherical bowl diameter given as 9 centimeters. So the radius is 9 by 2 centimeters. Immediately write the radius below it. The liquid is poured into diameter 3 and height 3. So this is also height is 3 and the diameter is 3. So here radius is 3 upon 2 centimeters. So how many we have? So how many bottles will be required to fill this? So that means we can equate both of them, equating both the volumes. So volume of a hemispherical bowl is equal to, yes, n, because how many bottles are filling it? We have to find n. I'll suppose n as a number of bottles. N volume of cylindrical bottles. So if you are equating them, that means we are equating the volume, means here the liquid we are equating. Right. Here the volume of the hemispherical bowl, we know the formula of the hemisphere, 2 by 3 pi r cube is equal to n into cylinder volume is pi r square h. So where pi value is standard, we can cancel it off, but we cannot cancel the r because here r cube r square, but here this is the radius of the hemisphere, that is different, and here the radius of the cylinder, we cannot cancel r here. So that we will substitute 2 by 3 into r. R is the radius of the hemisphere, that is 9 by 2 3 times. Given 9 by 2, okay. Yes, diameter is 9 centimeters, so the radius is 9 by 2 equals to n into this r is the radius of the cylinder, 3 by 2 twice. H value is 3. Right. So here if you want n, we can shift this all this to the other side. Here this is the h value is n, right. So let us shift here. So 2 by 3 into 9 by 2 into 9 by 2 into 9 by 2, all this will become the reciprocals if they are shifted to the other side. So 2 upon 3, 2 upon 3, and this is 3 upon 1, so it becomes 1 by 3. Here this gives n. So I have shifted all these terms to this side, so all these fractions becomes the reciprocals. Now here we will cancel it off. 3, 3, 3, 9s, 9. 3 3s are 9. Okay. The other also 3 3s are 9. One more 9 goes off. Here 2 and 2 will go. Here 2 and 2 will go. Here 2 and 2 will go. So what is remained here? So only n. N equal to 9. So what is n? The number of bottles. Number of bottles. N equal to 9. Okay. No any centimeters because these are the numbers of bottles. They are not any measurements. Okay. Number of bottles. So 9 bottles full of liquid will be, if that liquid is shifted to the hemispherical bowl. So 9 bottles are required to fill this hemispherical bowl. Okay, pause it and note it down. With this, we have come to the end of the exercise, right? End of the exercise 10.4. We will, so with this, we have come to the end of the chapter as well. So there are 13 parts in this chapter. So this is the 13th lesson, video lesson of surface areas and volumes. Do watch all the 13 parts. Hope you have understood the concept well, practice well. Thank you all.